Okay, so we're going to look at another sort of game of chance, and that's flipping a coin 3 times. And again, this is one where we want to construct the sample space first. If we have a good sample space, then all of the probability questions for this become much easier. So to start with our sample space from flipping 3 coins, then find the related probabilities. So to draw this sample space, what I want to think about is, okay, I'm either going to have a heads first or a tails first. Okay, if I have a heads first, draw a line here, then for the second roll, I'm either going to have heads or tails. So I'm going to, for this heads first, I'm going to do it twice. I have a heads first, and then I either have a heads and then a tail, heads and then a heads, or heads and then a tail. And same thing, if I roll a tail first, I'm either going to have tails and then heads, or tails and then tails. So this would be the sample space for flipping a coin twice. We want to flip the coin 3 times. So this would be right over here, two flips. So basically, for each of these guys, each of these 4 choices now have a choice of heads or tails. So I'm going to keep this sort of line here in the middle. So for this one, heads, heads, I'm going to have heads, heads. I could have a heads, or I could have heads, heads, and then a tail. For this second one, heads, tails, I could have heads, tails, heads, or heads, tails, tails. So those 2 are giving rise to 4 outcomes. This one looks a little weird, sorry. And then downstairs below this line, for each of these, again, I could have heads or tails. So for the first option of tails, heads, I could have tails, heads, heads, or tails, heads, tails. And then for the second option, tails, tails, I could have tails, tails, and then the third flip being a heads, or tails, tails, and the third flip being a tail. So you can see I have a total of 8 possibilities with the 3 flips. If you think about some of the later stuff in this chapter talks about a counting principle, here you have 2 flips of the coin, so that's 2 choices, heads or tails for the first coin, and 2 choices, heads or tails for the second coin, 4 outcomes in the sample space. Over here you have 3 flips, so first, second, third, 2 choices for the first flip, 2 choices for the second flip, 2 choices for the third flip, 8 outcomes total. So what we want to be careful of is to list them all and to not miss one. So the way that I did that was very systematic. You might try this yourself. Usually we don't go beyond 3. I mean, if I went to 4 flips of the coin, that would be 16 outcomes. So that would be a lot. For a sample space, we generally use sort of the curly brace, and then I would list all the options inside those curly braces, which I have done on this next screen. Heads, 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 tails, heads, tails, heads, etc. A total of 8 options. And now we're going to look at finding probabilities, and we're going to use that sample space to help us. So you could pause and write down these 1, 2, 3, 4, 6 problems, maybe 2 or 3 lines in between each. And again, just like the rolling of the die problem, we're flipping a single coin 3 times. So we know which one is first, second, and third. So that things like heads, heads, tails is different from tails, heads, heads. Whereas if I just threw 3 coins up in the air, those 2 things would be the same, 2 heads and a tail. But because I'm doing 1 coin consecutively, the rolls are considered different. Okay, first problem, probability of getting all tails. There's only one way to do that, and that's get tails, tails, tails. So I can just write that in here, tails, 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 for my notation. And then there's only 1 out of 8. And once you have the sample space and you use the proper notation, the result is pretty straightforward. The next one, the probability of getting exactly 2 heads. So I'm going to write in probability notation rather than listing them all. I'm just going to write it in words. The probability of exactly 2 heads. That's fine. You can do that with anything. You can just probability of whatever it was. The first one I just went ahead and listed it because it's so easy to list out. Tails, tails, tails. Exactly 2 heads. So I go upstairs here. That first one doesn't count because it has 3. That guy has exactly 2. That guy has exactly 2. That guy has exactly 2. And none of the other ones have exactly 2. So this is 3 out of 8. And again, I probably would avoid like crossing them out because you're going to want to use them in the next problem. So potentially. So, if you do cross things out, then sometimes it's helpful to rewrite the sample space. The next problem, find the probability of only alternating flips. So that means if I start with a head, the next flip has to be a tail, and then the next flip has to be a head. So there's one of them, heads, tails, heads. And if you have a bunch of problems that you're doing, you have a different way of notating which one's which, that will work too. And then if I start with a tail, the next one has to be a heads, and the last one would have to be a tail. So there are 2 options that have only alternating values. Again, it's 2 out of 8. So if you're entering that in as a fraction in, say, WAMAP, you would want to reduce it to 1/4. Okay, back. Little computer issue there. So I think we just did the probability of only alternating flips. Now we're looking at the probability of all heads, conditional probability, given that the first roll is a head. So again, I'm going to look at the sample space, and when I do this problem, I don't need to use a formula. I can just go to my system of figuring out how many of my options have the first roll being a heads. Well, that's these first 4. And then I'm going to say, well, out of those 4, how many are heads, heads, heads? All heads. Well, there's only, out of those 4, there's only 1. That's heads, heads, heads. So 1 out of 4, or 0.25. And I'm having some computer issues, so I don't know why it's doing this. Sorry, now I can't get it to pause either for some reason. Let's try that. Well, I might have to stop this recording. I'm trying to stop it, but it won't let me stop it. So, oh, there we go. Pause recording. Okay, we're back. The last one, 1 out of 4. Next one, probability of at least 2 heads. If I look at my sample space, I'll just go through and count how many of them have at least 2 heads. Maybe I'll just do this with the font here. Well, that one has 3, so that's more than 2. That has at least 2. That has 2. That also has 2. So there's 3. That only has 1. This one has 2. That has 1. That has 1. That doesn't have any. So it looks like it's 4 out of 8. Or 0.5. And then the last problem, probability of at least one heads. I'm going to do this 2 ways. If we think about, how many have at least one heads? Well, it's anything that one of the roles has a head. So it's all of those, and there are 7 of them. 7 out of 8. So we're done with that. But I could also think about, and this is useful when we can't figure out the first part. When we notice that at least one, when we're looking for the probability of at least one thing happening, I can think of it as, look at all the possibilities, that probability is 1, and subtract off the one where there are no heads. So the probability of at least 1 is the same as 1 minus the probability of none, or the probability of no heads. So I know I already did this problem sort of directly by counting, but there's several other problems that we'll see later where it's actually easier to figure this out by taking 1 minus 1/8. And then that is equal to the same thing we got before, 7/8. 0.875. Okay, so that's that example. Sorry about the computer glitches. I hope that's not too bad to watch. Those are the sort of the 2 games of chances, rolling a die, flipping a coin. You could combine those 2. You could say, find the sample space from flipping a single coin and rolling a die. So you'd have heads first, and then you'd have rolls 1 through 6. And then you'd have tails and rolls 1 through 6. So that would have 12 outcomes. You could talk about sort of having a different sided die, maybe a 3-sided die. So you could flip a coin and roll a 3-sided die. So that would have heads with rolls 1, 2, 3, tails with rolls 1, 2, 3. That sample space would have 6 items. And again, I would list them out. You could talk about sort of rolling a die where one die has 3 colors on it, so red, yellow, or blue, and another die has the numbers 1 through 6. And you could have red 1, red 2, red 3, blue 1, blue 2, blue 3, etc. And again, you would want to list out all of the options. And by listing out all the options in the sample space from the get-go, it's much easier to figure out and answer all of the probability questions that are associated with it. All right, so that's flipping of 3 coins, or flipping a single coin 3 times. Thanks.